Right, so we're at question number 12, and we're trying to find the broadcast ID in that network. Very easy. How do we do it? 172.16.16/22. So let me see, 172.16.16.0/22. To find the broadcast ID, it's important to find the next network. That's the easiest way to find the range of IP addresses. Find the next network, basically. How do we find the next network? We have /22, meaning we have 22 bits that are being used for, okay, I get it. 22 bits that are being used for the network portion, leaving 10 bits for the host portion. What we call a broadcast ID, we can easily identify it by this portion, these 10 bits for the host being all ones in a network. Those 10 bits, if they are put to all ones, that is equivalent to a broadcast ID. I think that's the easiest way to do this. What do we mean? First, 22 bits. So 22 bits through Gumera Papa, let's identify the portion your network prefix is changing. So 22, 8 panap, 172 I change. 16 panap, 16 I change. Then 22 are somewhere right here. So 6 bits, the panap, and the change as well. 6 bits, the panap, Tinechi. So if we zoom in per two my numbers are, we get 16, 128, 64, 32, 16. That's 16, 1, 2, 3, 4. Then dot 1, 2, 3, 4, 5, 6, 7, 8. So the part here, let us zoom in here in at 16.0 ndo yapanapa. Then 22 bits zedu dzenetwork dzikuperera pana 17, 18, 19, 20, 21, 22. Dzikuperera pana. Toatasarawo ne 10 bits dzandataura idzo dzekuhost portion. Zvinoreva broadcast, it means host portion yese ama 1. Ma 1, what do we mean? So it means if you convert these bits to 1, 1, if you convert these bits to 1, 2, 3, 4, 5, 6, 7, 8, do you know the broadcast address issue? Inotipachi, I just remove this and I zoom out again. If I zoom out, panapa pana pana now, panapa pana pana now, panapa pana pana 255, this one is easy. Then panapa pana 16 plus 2 plus 1, 18, 19, pana 19. Meaning our broadcast ID is 172, 16, 19, 255. I hope we have an answer like this one. If not, voila, this one. That's how you get your broadcast ID. Let's have another example. I think there's something to learn from a broadcast ID app. How do you identify broadcast ID? Let's look at another example. Your addresses are really familiar with. Let's look at my network Satambo Dilana open up. Let's look at network in a network ID. This one ends the network here. Okay, this one ends the network /28. I think this one is easy. Let's look at this one. Now /24. In 24 slash 28. Let's look at this network. Tova that let's find its broadcast. Kana toda kutsvaga broadcast network iyi, the easiest way yatinoziva is looking at this table. Wotarisa kuti manetworks akaita sei pana /28. Pana /28 up. Manetworks is 16, 16, 28. 16, 16, 28. Meaning achatengera pana 0, oti 16, oti 32, oti 60, no, oti 48 plus 16 plus 16, 64. Panosvika pana 64 plus 16, 0, kwenda 1, so 6, 7, 8.80. So it's very easy. Ndikashandisa numbers ndotsvaga broadcast. So if I look at this number, then I can identify to 79 ndo broadcast ishi yenetwork ishi. Ndichishandisa table, that's how I identify it. 80 next network, 79 ndo broadcast, 78 ndo last address. Now using methods yama all ones. If I look at this number, /28 means I am a bit side, they won't be affected. 8, 16, 24, they won't be affected. This part is which affect way. If we zoom in, 64 is 0, 1, 1, 2, 3, 4, 5, 6. That's our 64. /28, apa pane 24. 0 panapa pasara 4. 1, 2, 3, 4 panapa. Ndozvikureva kuti kunoku ndoku network uku, kunoku ndoku host uku. Kana takuda kutsvaga broadcast, it means the host side ese akuchinja kuita chi ma1. Esa 1, 2, 3, 4. Then we zoom out, ndoti tiwane broadcast. If we zoom out, number iyi inoita chi ishi. Number iyi inoita 64 plus 64, 32, 16, 8 plus 8, 4, 2, 1. So 64 plus 6 is 70, 78 is now 1 is 79. Dot 79, which is the same as dot 79. We are up. So many ways to slaughter a cat. Very important kubata both ways so that you know where to apply it easy. This one from /24, /25 to /31, if you get a network yakadai, uchitongopinda muexam, nyora your table ish. I think that's a must. Excuse me. Uchingopinda muexam, nyora table E. Because the question, you definitely get a question which will require you to use that table. That is if kana ukapiwa network in a /25 up to /31. Ukapiwa network in a prefix length are below that. Then you need to use knowledge yako, my binary numbers. How do you find, for example, the broadcast oceans my binary numbers, zooming in, zooming out. So got to read out. But if not, then don't waste time. Shanta this method you table. So pan up 2 methods to find in the broadcast basically. Right, let's continue with our questions. Let me see. Number 13, a site administrator has been told a particular network must accommodate 126 hosts. Which subnet will be used? 126 hosts without wasting our time. Table redu. 126 hosts, ziripapa. Ipanapa, definitely. Meaning we can create 2 more subnets. 126. Question to do again. Subnet mask. Subnet mask dot 128. This one. Very easy. Or if you want to go the longer way, 126 hosts. 126 hosts. What does that mean? It means we have how many bits that we need for the host portion. 2 to the power of n minus 2 is equals to number of hosts. So if number of hosts is 126 per now, 2 to the power of n minus 2, what is our n? A little bit of mathematics will tell you, no answer remove this, do understand 128 kuno. 2 to the power of n. Our n, we can easily identify it, and 7. So meaning 2 to the power of 7 is equal to 128. The number of bits that we need for the host portion is 7 bits. So if we require 7 bits for the host portion, what would be our prefix length? 7 bits for the host portion, it means kuno 7 bits, kuno kwasara mangani 25. So this is the host portion. This becomes the network portion. Then can honor the network portion that can easily lead you to the prefix length. Can honor prefix length that can easily lead you to .128. Very easy. Because slash 25, what does that mean? It means 8 my ones, 8 my ones, 8 my ones, tapa 24. Name 1 banana, which gives us .128. No power .128. Then I and Doma 255, 255, 255. Our answer is B. Right, easy. Many ways to slaughter this kit. Number 14. So panapa answer B. Number 14, refer to the exhibit. My questions are my exhibit and do are trick in CCNA exam. From experience. Why my questions are not exhibit very tricky. Right. Considering the address is already used and having to remain within the 10, 16, 10, 0, 24 network range, which subnet will be assigned to the network containing 25 hosts. So already used the I /26 and /28. Takuda accommodate 25 hosts. Let me refer to my table quickly. Panapa, since we are using a /24 network, so it makes it easy to refer to the table. So ndikadzoka ku table ndoda accommodate 25 hosts. Which subnet do I use? Where pano 25/25 euro. 25 addresses. Ndinoshandisa this 32, 8, 27. 32, 8, 32, 27. Ndo manamba dzandoshandisa. So ndikaya panapa ndikati 8, 32, 27. It can guide me kuti answer yangu ichabuda sei. Answer yangu inofanira kubuda definitely in a /27. So this is wrong, this is wrong, this is wrong, this is wrong. Answer is between these two. Right? Which one is correct though? Ndikatarisa .64. .64 inenge yatoshanda ka. Because panapa tatopana .192/20. Yashanda. Yasati yashanda. Yeah. Imwe yacho ichi .240. Okay, let's look at my networks. Let's make it easy. This is the guesswork. Let's look at my networks and pana 832.27. My networks are report no one at .0, .32, plus 32,696, .32,8,128, .32,160. One last one. Let's see if 192. Tumbogumele papa. Because hapana number for 240. We get 192 plus 32, 224. Is that correct? Let me see. 192 plus 32, 224. 224 plus 32, I think, into 8. 1, 2, 3, 4, 5, 6, 7, 8. Aquan. Right. So my networks are create when 832/27. So this one, obviously, .64 network ish. Iripap. Inokwanisa kushandiswa. But .240 mukuiona network /27 haipo kapi. Meaning .240 is the wrong answer ish. Kana tishandisa /27 hakuna .240. My networks ariko ndo arapa esa. Then if I want to expand answer yangu probably kungoratidza knowledge yako panapa pana /28 apa. It means number of addresses ziripo apa. Maximum number of hosts ziripo ichi. The reason why 64 yazoshanda 28, 16. So maximum is 16. Less than 14, it should be 14, but now 14 addresses. So muno network ish. Muno 14 addresses and below. Then in a /26 ish, muno 62 and below. And the reason why 64 yazoshanda, because munomu ndo machatanga kusubmit omune VLSM, munomu ndo machatanga kusubmit, then toya apa, then tozoya apa pekupedzisira. Easy. Pakusubmit, tinotanga kusubmita with the most requirements, most hosts, let's say, tichidzika. So iyi ndo inotanga kotera ishi, then kotera ishi. That's the reason why 64 yapinda. Ndachidomboiramba because ndandaona kunge ndoichaita namba yekupedzisira in the submitting order. Right, easy. Let's move number 15. What is the usable number of IP addresses on a network /26? 62. Zvafana kuya easy now. Ukadzokera kutable inodzosa pa62 /26 /25 128 26 25. I mean, it's 128 26 64 minus 2, obviously 27 32 16 uchidzika uchingoenda wakadaro. Which address prefix is reserved for multicast? Multicast inoshandisa 224. I think so. 240 ndeye multicast inoshandisa, I just know 240 ndonziona pakawanda inoshandiswe kupi. Zero are reserved for experiments and whatnot. You need to identify my address ranges. I think asipo cheta apa class A, B, C. Then multicast yako aya ndo anoshandiswa apipa automatic is aipa or apipa. Then aya ndo anoshandiswa loopback interfaces. You need to know range my IP addresses. Aya, I'm thinking do I reserve for whatever that is. Yeah, let us go back and confirm this. And I also need to refresh my brains. 13, 11, let me see. Panapa address classes. Address classes are to be up. That was VLSM 7.8. Class A, B, and C. I need to identify. Then we have class D, which is the multicast. 224 Irabai. Funny enough, we take some answers yes and Angari, but I'm for it. 224 multicasting. Then 240 experimental address block ED. Then come as no 169 EDP. Kana yema loopback pop. Okay. But you can also do some research from at least now for my identify which is related. 127.00.1 do address nations was a loopback interface. Then go IPv6 loopback interface kwa IPv6 ningeketa same. Sure. A multicast thinking among FF00 range to multicast or loopback interface. Depend on a loopback interface in chat. IPv6. What does it look like? So then we give an excuse as when you're exam. Let's continue. Refer to the exhibit, mesh the network with the correct IP address prefix that will satisfy your host addressing requirements for each network. Okay, place the options in the following order: network A, B, C, D. All right. So network, let's start with the network A. In 100 my hosts, slash 25. Okay, dot one. Okay, double colon one. And then the loopback interface. Got default routes. I think it's in a zero default routes. Right. 100 hosts. Rekantasha network yangu slash hapa tisapedza nguva. Yes, slash 25, 26, 27, slash 24 iri subnet kwenu. So 100 hosts, 2, 128 slash 25 ish. Ndiye tinoshandisa pa100 mahosts iyo. So slash 25 network inoshanda pa-network A. I think ndo answer correct. I think akatomechwa kudhara. Then toenda pa-network B, 50 mahosts. 50 mahosts, ishandisa 464, 26. That's where we are getting our first network ish. Correct. Slash 26, first network dot 0. Then network C, 25 my hosts. The chance in a 32 ish. In 32 in 8, 32. Inenge chance my bits mangani 27. Inenge chance 27. Is that correct? I think so. Yes. So ndo unotora network iyo 96 iyo 96 yacho irubva papi. I think irutora network yechingani. So plus 32.64 panapa plus 32.96 ndo network yatorwa ishi. Ndo iyo correct. Then network D 2 mahosts tichashandisa chiapo na slash 4 slash should be 31 or 30. 31 or 30. Let me confirm. 34, 64 subnets. So it's 64 4 slash 30. 64 4 slash 30. So this one is 64 4 slash 30. That's what the answer in a slash 30 you will answer. I think very easy to identify my answers for that one. 18. My questions and my diagram and my questions are you get very impatient in the exam. I know I had my paragraph here. They test your patience, but with practice, you will learn to be very patient. Always attempt my questions. I like whoever came with the idea able to revise this because that's the best way to learn. After all theory, you practice. You practice my questions. You see how to respond to my questions. Right. Yeah, high school in New York is using video conferencing to establish students' interactions with another school B in Russia. So New York, in New York, La Rus, in Russia. Right. The video conferencing is conducted between two end devices through the internet. Okay. Remote network. The network administrator configures the end device with IP address 209.165. That's a public IP. So now we have an IP address 209. The administrator sends a request for the IP address for the end device in school B, and the response is 192.168. Address here, 192.168. That's a private address. So kunok to a public, kunok to a private IP address. Neither school is using VPN, okay? The administrator knows immediately that this IP will not work. Why? This is a loopback interface. No, hapana loopback interface up. Automatically this goes. This is a link local, hapana link local. This goes. This is a private IP address. There is an IP address conflict. Hapana conflict iripa. IP address akasiyana. The reason why there's going to be a problem and this will not work is because these are two networks, two different networks communicating through the internet. So if we are communicating through the internet, we use my public IP addresses. You will never see a 192 over the internet. That is a private IP address. So the reason why this network will not work is because private IP address E was being used to communicate globally, which should not be the case. And that's why the answer is C. So without you knowing range my private IP address chi, then what is the range my public IP address? You will not be able to understand this is written at that type of a question. Without you as well understanding it, when we are communicating over the internet, we use my public IP addresses, not my private. My private, they are for private communication within the local network. Then we can do that. But when we go to the internet, we will need public IP addresses. Number 19, which three addresses are valid public addresses or public addresses? So for me, it's easier to identify my private. So my private 30, 10/8, 172.16/12, then 192.168/16. Do my private. 192.168, iro, i-private, rinokwana apa pana /16 apa. 10/15, iro, i-private, iro, rinokwana pana 10 apo. Then 128, which three addresses? Okay, three addresses in the public, those are true. 10, 15, inokwana. 172.16/12, 31 inokwana. Then 64, apana 64, public-ish. I see private-ish. But I think bottom side are 3. 128, apana 128 up from address I. Apana 128 E goes. 198, apana 198 up. This one goes. So one my X and no my public IP addresses. Very easy. Very easy. I think it's also beneficial for you to find the range. I am a network, sir. But what are the range of IP addresses? It's repo. So it's very easy. So you can see, let's slash with, let's do the last one, 192.168/16. Let's find the range of IP addresses, remove 192.168/16. So basically, the full format addressing again .0.0/16. So this is the network ID for private addresses. Then the range, obviously, the first address will be 192.168.0. Let's just say call it .1 up to 16 bits being used for the network, 16 bits being used for the host portion, meaning the last address we can get this tinoizuma ini toisa ma-01s, because 192 8 bits remains like that, 168 8 bits remains like that, but this part ichachinja kuita 255, imwe yacho yochinja kuita 255. So the range of IP addresses yatinoti private iri kubva from here to here. That's how you find my addresses. So ukatotarisa 198 hapana. Ukatotarisa as well, I think imwe ritricky ina 172 izvo. Iri tricky pakuziva kuti iri kuprivate here kana tiri kupi. Let's look at 172. So it's 172.16.0/12. Right, the range, from this point kusvika papi, tine 12 bits up, meaning 172 remains the same 8. Then we need to zoom in panapa. So 16 anoita 1 128 64 32 16 1 2 3 4 ndo 16 uyu. Kuno kutina .0.0 hatinetsi. Panapa tine 8 up. To get 12, I'll take these ones, meaning this part is will remain the same rakadai so. Right. So ndikawana all ones kuti ndiwane the last address, ndikaenda ndikachinja all ones panapa 1 2 3 4 panapa pachaita all ones yoita 255.255. What becomes of this part yoita zuma in is 172. Here we have 16. This is 31. 16 plus 8 24 plus 4 28 plus 2 30 plus 1 31.255.255. So ukadatarisa address ish iri apa ina 31 ish, it means it falls under private IP address. Maquestion mamwe kana uda kuvekisa anogona kungova baba oti 172 32 125. Hey bana, what's happening? Oti 25. Iyo wajera kuona 172 pama private IP addresses, pamwe wajera kuona ina 16. Ungoti pamwe inenge irimo muprivate imomo because iyi haisi private IP address ishi, because range tatokudzidzisa kuitsvaga. So uchipinda muexam ndo mamwe matricks, iwo unongobata the network ine maprivate IP addresses, the network. Then kana wakutobvunza specific addresses, you find the range on your own, unyatsoona kuti inopinda ine murange. And you can clearly see this one IP name range because ina 32. Range yedu inogumira pana 31 pana. Right, number 20. A message is sent to all the hosts on a remote. The type of network that we have is the type of message. Easy. Chimbomuka ya mchatu. Pema answer. Number 20. Vukane mchati. Vukane. A limited broadcast, a directed broadcast. What's the difference between those? What's the answer here? C. Direct broadcast. What's the difference between a limited broadcast and a direct broadcast? A message sent to all hosts on a remote network. Which type of message is it? Parents have the difference between this. Quick Google. Let me do this. Yeah, my head is blank on that one. Quick guess. Who's quick guess? You think I'm a quick guess in limited, maybe limited to a local network. Okay, maybe. Difference between limited broadcast and directed broadcast. Let me look at this. Type of broadcast strictly confined to a local network. Sharing is on fire. It does not cross router boundaries. Then we have direct broadcast designed to reach all devices within a specific network, even if the sending device is on a different network. I was very happy share on that. That wasn't a quick guess. Impressive. I like that. So limited, local, directed, remote. Easy. So our answer here is what? This is our answer, directed broadcast. Donkey. 4 minutes. Let's go. The company has a network ID 192.168.64. Ndichingoona .64 yanzi network. Musoro mangu muruto funga /26 isataenda kucho. Although EC provide from answers, but let's go with the subnet mask of .192. The company wants to create two subnetworks that would contain 10 hosts and 18 respectively. Which two networks would achieve this? Okay, let me take note of this. Let me look at this. So in my networks 192.168.164. 164. So I have 192.168.164 with the mask in .192 for the subnet mask. Then we want to create some subnets. One with 10 hosts, then the other with 18, I think. 18 hosts, let me just confirm. One with 10 hosts and 18 respectively. Which networks would achieve that? All right, a little bit of subnetting, VLSM, Shanda. So, Panapa .192, what does that mean? Let me drag page, let me put page here. .192, ndikadzokapo kuno kupitable yedu. .192 means /26. So it means Panapa /26. Let me do this. Kana ndiri kuda 18 mahosts, kana ndichisubnet, ndinotanga subneta ndichitora requirements akawanda. So ndichatanga subneta using this one. That's how VLSM works. 18 hosts. If I want 18 hosts, it means I'm using 32, 8, 27. Ndadzoka panapa. Open 18 hosts. Pano ndopano budira. Right? So 8, 32, 27. Do I injection this? The first network that I will get will be the same as this one with a different mask. 192.168.164/27. That's the first network that I will get. Do I injection this for 18 hosts? Then do end up another network and try to further subnet. I hope to get another direction to test some answer after. So the second network, I add this 64 plus 32. This is 696/27. I further subnet this to accommodate 10 more hosts. To accommodate 10 more hosts, I use 16, 16, 28. Which means I can move from 27 here to 28. That's how I'll accommodate the 10 hosts. And these are the two networks that we can use. Using subnetting, very easy. So now let's go to our answer. So we have .64/27, .96/28. .64/27, .96/28. Roman networks are tertiary. These ones are all wrong. Easy. Right. 1 minute left up, I think. Let's call it a day. We continue. Let's see tomorrow. I think, yes, we can do it tomorrow. We finish off the rest of the checkpoint. Thank you very much for your time. Good evening.